Hello guys, I'll see you again. So in this video, I'm going to continue. I'm going to pick up where I left off in the last video. So that means I'm going to continue to go over the precise definition of the limit in 2.7. So last time we've expressed the limit in terms of the epsilon and delta like this. I know this is some kind of specific example. So where's this epsilon? So here epsilon is the replaced by zero point 0.1. Anyway, so now we want to generalize this expression for any epsilon, the value epsilon. Okay. So the f of x, what was f of x? F of x is the piecewise polynomial function, right? Right there. So, and then we just, last time we got the answer for the question, how close to 3 does x have to be so that f of x differs from 5 by less than 0.1. All right, so now then see that. So on equivalent formulation of our problem is to find the number delta such that this, right? Okay, so um, I'm sure that you are now, you just are familiar with this. I mean, yeah, so please get the hang of this expression. Okay, so now what if we choose the delta as 0.1 over 2? So where the 0.1 comes from? 0.1 is specific value of the epsilon. Okay, so we divide that specific value of epsilon by 2, so we got 0.05. So then the absolute value of f of x minus 5, we wanna just substitute the definition of f of x into the f of x in this expression and then simplify. That's what we're going to do. Do that, we're going to get this 2 times x minus 3, absolute value x minus 3. But see that absolute value x minus 3? That's the what? The the distance between x and 3. So we set this one is less than delta, and then we choose delta is epsilon over 2, which is 0.05. So 2 times absolute value of x minus 3 is less than 2 times delta, which is 0.1. So 0.1 exactly same number as the specific number what we choose for epsilon, right? And then if we want to find out the delta so that f of x minus 5, I mean absolute value, is less than 0.01, then we choose the delta as the 0.01 over 2, then we're going to get 0.01 right here. And then similarly, we're going to, if we want to find out less than 0.001, and then if we generalize epsilon, then we choose the delta as epsilon over 2, then finally, we're going to get this. So now you see that we got the formula, I mean the relationship between epsilon and delta. So whenever we choose arbitrarily, whenever we choose the value for epsilon, then we choose delta as that epsilon over 2, and then f of x minus 5 must be, I mean distance between f of x and 5 must be less than epsilon. So from here, we're going to get clue how can we determine the delta for any value of epsilon, right? So before going further, let's just the what just crystal clear the new definition, I mean precise definition of the limit. So now if for any number epsilon, there is a corresponding number delta such that absolute value of f of x minus L is less than epsilon if x minus absolute value of x minus a is less than delta. Okay, so I mean, greater than 0, yeah, you can mention it, but that's just obvious, right? Absolute value must be greater than 0, right? I mean, greater than or equals 0, but x cannot be a, right? So that's why just equal sign, that inequality just taken out. All right, so now we move to the part 2. Okay, so how can you find delta? All right, so we got a clue. How can you find out delta? I mean, how can you get the relationship between epsilon and delta right there, right? So the here, this one is talking about the symmetry something, but before I'm gonna go over this one later. So let's look at the part three, how to prove the limit. All right, so example one gives an illustration of the definition of epsilon point 2, but it does not prove that the limit is equal to 2. A proof has to provide a delta for every epsilon. Okay, so what is the example one? Yeah, so see, give me a second. All right, so example one, we're gonna see later. Okay, so that's the example one is in part two, but I want to just cover part three first. Okay, so step for proving the limit of f of x as x approaches a equals L. So the to find out delta for any choice of epsilon, first one, the see we have to do two steps. The first one, find the delta. How can you find out? Let epsilon be an arbitrarily positive number. They use the inequality f of x minus L absolute value less than epsilon to find the condition of the form absolute value of x minus a is less than delta. What that means, starting from this absolute value of f of x minus L, and then the doing some algebra, okay, simplifying or factoring or dividing or multiplying the express that absolute value in terms of the absolute value of x minus a. Okay, all right. So now that's the first step, so that then we can find out the relationship between epsilon and delta. Okay. The step two, once you figure out the relationship between the delta and epsilon, then write a proof for any epsilon is greater than zero. Assume that you know the absolute value of x minus a is less than delta. Use the relationship between epsilon and delta, the found in step one, to prove that absolute value of f of x minus L is less than epsilon. Okay. So all right. So now we see. Mm, example two. Prove the limit of that the rational function as x approach negative 1.5 equals 6. Okay, so f of x is given, and then the L is 6, and the A is negative 1.5. Step 1, find delta. In this case, A is negative 3 half. Yep, and the L is 6. Yeah, I told you. All right, so now we're gonna start from this. Okay, absolute value of f of x minus 6 is less than epsilon. Now we wanna what? We're gonna simplify the quantity inside the absolute value. Okay, so 9 minus 4x squared over 3 plus 2x. So yeah, this top one, definitely we can factor, right? So 3 plus 2x and 3 minus 2x, yeah, and then 3 plus 2x is cancel them out, right, in top and bottom, right? So we got just a polynomial, 3 minus 2x minus 6. Then now, the somehow we have to express negative 2x minus 3 in terms of x minus a. Okay, so what is x minus a? X plus 3 half, right? To to get that, we're gonna take out 2. Okay, so factoring out 2, we're gonna get this 2 times absolute value of x plus 3 half. You see the x plus 3 half, right? So this is x minus a, right? So now then x absolute value of x plus 3 this one anyway, so that one is equivalent to this one, right? Okay, so I mean the left hand side is equivalent in the first inequality must be equivalent to the that expression. Okay, oops, yeah, that expression in that inequality, right? It means that this one also must be less than epsilon. Now we're gonna divide by 2 to isolate that absolute value of x minus a. So we got epsilon over 2. But this one, I mean, that absolute value must be less than delta. It means that delta must be epsilon over 2. So whenever we choose delta as epsilon over 2, then that f of x minus L must be less than epsilon, right? So that's the how to find out the relationship between epsilon and delta. So now we move to step 2. For any epsilon, let delta is epsilon over 2, then absolute value of f of x minus 6. We just did that, right? We just did that simplify that algebra expression. So we got this. Now what we set for delta, what delta is epsilon over 2, so that one must be less than epsilon over 2, but there is a factor 2, so 2 times epsilon over 2 is just epsilon. Okay, so yeah, so f of x minus L must be less than epsilon whenever fx minus a is less than delta. Okay, so step 1 is to find out the delta starting from the absolute value f of x minus L, and then applying some algebra to figure out the relationship between epsilon and delta. And then step 2, the for that, based on that statement, we just prove that limit. Okay, so this is, I just visualize that limit in example 2, what we did. Okay, right here. So if epsilon is, for example, 1, then we choose delta is what? The 0.5. Okay. So if the epsilon is 2, then we choose delta is half of epsilon, which is 1. Okay. So for any epsilon, we choose the oh, that's not, give me a second. Yeah, kind of, it's hard to match the epsilon delta, but anyway. Okay. Yeah. So whenever delta is bounded by number, then the f of x must be bounded by that L within epsilon, right? Okay, so that's for today. Look at this video. I mean, so now the next video I'm going to cover the part 2. Okay.